good stuff to go over today. I'm going to do things a little different today, too. I usually just go page by page through the buzz lesson. You guys can do that. I know you can go to the buzz lesson, so I'm going to provide some teaching outside of that today and try something a little different, because if we try to go through this page by page, we'll be here an entire hour and a half, and I don't even know if we get through it all. But doing it this other way, I think I can get through everything a lot better without relying on every little thing that Buzz puts into it, because you guys have access to that. I don't need to duplicate what you can go look at yourself. There's some little cartoon videos in there this week and stuff, so you can go look at that. But let me put this up first. There you go. Which Ed Sheeran shows how you're feeling today? Pick an Ed. I think number 3 is an AI Ed. I don't think that's a real Ed Sheeran. I don't think that's a real photo. So Leo's a 5. He's the bored Ed. So is Logan. Aaron's a happy Ed. Happy Ed looks like a real photo. I think that one's real. I think number 2 is an AI photo too. I'm not sure if any of them are real. Maybe number 1. The others look just a little bit too fabricated. Number 4 looks a little creepy, actually. That hungry. Number 4 looks like zombie-ish hungry, like he's eating brains or something. I don't know. 5, 4, some ones. 4 to 3-ish. Alex going to kind of give it in between there. Get a 5. Oh, John thinks they're all fake. Maybe. I don't know. Most of them, I believe, are fake. But one's kind of got me convinced that might be a real photo, but I don't know. Maybe not. Hard to tell. Just to Ed up your day here. Just get y'all started. A little Ed Sheeran there. You never have too much Ed Sheeran, right? Okay. Well, maybe not. Well, we will look at where we're at in our class today. Let's see, 5th hour right here. Let's go to our grade screen as usual. All right, so last week we had the sum and difference of cubes and graphing quadratic equations. Oh, no, there's a video I need to load up for you guys too. This week, we actually have 3 lessons, but that's because 2 of them, they really go together. We shouldn't really do one without the other. We have completing the square, which is a very interesting method of solving problems. And then we have solving quadratic equations and solving quadratic equations with complex solutions. That's really the same lesson. They just take it up one level in the answers. So we're going to look at all 3 of those things today in completing the square. I'll show you the first little. I'm not going to play the cartoon, but there's a little goofy cartoon. They're getting in the habit of throwing these goofy cartoons in here. So you can go back and look at this. I'm not going to play in class. It loads very slowly today. But there it is, right off the bat. Got this little completing the square cartoon. That's a minute and a half. So there you go. You can go look at it later and see these little cartoon characters and the terrible acting and even the voice acting. I think the voice acting may be a computer as well. I don't even think it's a real person recording the voices. I think the whole thing's computer generated, and it's really hokey. So anyway, I'm gonna switch over and we're gonna work some problems as I explain how to do these things, rather than going through all the stuff on Buzz that you can look at yourself. I don't need to hold your hand on that. Instead, we're gonna do this. So we're going to do something called completing the square. Completing the square. Now, why do we need to learn how to complete the square? All right, for really, there's a couple of reasons. So the first thing is, we've been looking at quadratic equations in vertex form. Like we had y equals 2x minus 1 squared plus 3, right? That was vertex form right there. And so we know the vertex is 1, 3. She's at a geometry pullout day. There you go. Miss Hartwell was looking for Miss X. Miss X is not in class today. So, and we know because of the H and the K, right, tells us that that is the vertex. But we've looked at before, what if we need this in standard form? Standard form is y equals what if the coefficient ax squared plus that coefficient plus c, right? That's standard form, ax squared plus bx plus c. That's the way we usually see a quadratic formula equation. But sometimes in vertex form. So to put this in vertex form, we just do the math. So x minus 1 squared is x minus 1 times x minus 1 plus 3. So let's distribute. So y equals 2 times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. And negative 1 times negative 1 is plus 1 plus 3. Simplify that. 2 times x squared. These are like terms. Minus 2x plus 1 plus 3. So this is distribute the 2x squared minus 4x plus 2, and then plus 3. So we can just change that to a plus 5. Because 2 plus 3 is 5. And this is the same equation as this is. Except this is vertex form, vertex. And this is standard form. Right, so we can have standard form and vertex form of the exact same equation. That's the same equation. We just did the math to change this into this. So what if I gave you this and asked for that? Like, well, I don't even know where to start. Exactly. That's why completing the square comes in handy, because we can take completing the square and turn this equation into vertex form. So let's work through that and see what we're talking about. All right, this is what we have to do with completing the square. And what do you mean the square? When we worked this problem, which I just hid from myself, where'd I put it? Right here. Oh, this part right here, that's what we get when we multiply x minus 1 times x minus 1, right? Because that's what we did, is we multiplied it together and then simplified it. So this is a perfect square trinomial. We looked at that before too in the last couple of weeks. Since this is a binomial and we squared it, when you square a binomial, you end up with a perfect square trinomial. Tri means three terms. X squared, negative 2x, and 1. That's a 3 terms. So it's a trinomial. Bi means 2. So there's 2 terms, x and negative 1. So this is a binomial. This is a trinomial. So this is called a perfect square trinomial. So when we're completing the square, that's what we're doing. We're going to create a perfect square trinomial. And we need to complete the square because right now it's not a square. So what we have to do is we have to get rid of this because this is not a perfect square trinomial. So let's get rid of the 27 by moving it to the other side. So we're not really getting rid of it. We're just moving it out of the way, right? So we have y plus 27 equals x squared minus 18. All right, so far so good. I don't even know that's the problem I wanted to start with, but that's the one I am starting with. I got another one we're going to do before. All right. Like, okay, now what? Well, now we're going to take this. Oh, almost messed it up. It's 18, x squared minus 18x, x squared minus 18x. All right, so move the 27. We're going to make this into a perfect square trinomial. So here's how we're going to do that. We're going to take this middle term coefficient, the negative 18. Okay, and we're going to divide it by 2. So what's negative 18 divided by 2? Negative 9. And we're going to square that. So what's negative 9 squared? That's plus 81. So I'm adding 81 to that side. Well, if I don't do that over here, I've changed the equation. So I also have to add 81 over here. I add 81 to both sides. All right. So now I'm still good. If I did the same thing to both sides, I haven't changed the equation. I've just changed what the equation looks like, but it's still the same equation because I sharpen that pencil. All right. So adding 81 to both sides. Now I can put those numbers together. Y plus 108 equals. So what is this? This is x minus 9 squared. I know that because I made it a perfect square trinomial by taking that middle term, dividing it in half, and squaring it. Because if you remember, again, where's the one I just did? Right here. If we have this and we want to make it into a trinomial, if you remember the formula for that, you would have a and b. A equals just x, b equals -1, and we would take the first term and square it, and then we would take 2 times a times b, and then take the third term and square it to get the perfect square trinomial. So if the original is x minus 1, the trinomial that goes with it is a squared, which is x squared, and then 2 times multiplying those together. -1 times x is -x, so we'd make it -2x. And then the third term, the -1, is squared, so that make it a +1. See, so using that formula, x minus 1 squared becomes x squared minus 2x plus 1. And we showed that right here by actually working it out, not using the little cheat formula here. That's the little cheat formula on how to jump to it. But that's what it is. That middle term is doubled. So going backwards, instead of doubling it, we take half of it. We divide it by 2. We divide it by 2. That takes a half of it. And then square it to get that last number, which is what we just did right here. We took that middle number and went backwards. And then we squared it on the end. So this is the same thing as this. It's just factored down to the x minus 9, x minus 9. We're almost there. If we move this 108 over, now we got y equals x minus 9 squared minus 108. Well, look, that's vertex. That's vertex form right there. The vertex would be at 9, -108. Vertex. Because this is vertex form. This is standard form. This is vertex form. You're like, okay, that looks wonderful, Mr. Brock, but I don't believe those are the same. Well, we can prove to ourselves those are the exact same. If we go up here to Desmos, graphing calculator, let's graph the original equation that we started with in standard form. So all we have to do is type in here, y equals x squared. Oh, I didn't hit the right one. X squared, there we go. Minus 18x minus 27. Oh, I only see a line. Well, I got to zoom out. Oh, look at this. Boy, the vertex is way down here at 9, -108. Hey, wait a minute. That's what we said the vertex was. Let's type in the vertex form and see if it graphs the exact same thing. It looks like it's going to, because that's where the vertex is. Y equals x minus 9 squared minus 108. Look at there. The blue graph and the red graph are the exact same graph. They're both upward facing parabolas that have the same vertex. And -27 is the y-intercept. We can tell from standard form, right? If we put zeros in for x, we expect the y-intercept to be at -27, and it is. So there's our vertex and our y-intercept. So we do that by completing the square. Completing the square. What else can we use completing the square for? Well, let's see. Oh, I had another problem that I worked earlier. Let's do another one before we move in. Let's convert another one to vertex form. And I'm going to make this one just a little bit different. 2x squared minus 20x plus 47. All right. Put a nice solid line across there. So now that's different. Okay. Now, how did we do that? We got rid of this first because we want a perfect square. So we're going to subtract 47. So this is y minus 47 equals 2x squared minus 20x. All right. Now, when I look at it, first off, I see there's a little bit of a problem because if we were going to use this pattern going the other direction, this has to be a perfect square and this has to be a perfect square, right? X squared is x squared and 1 is negative 1 squared. Both of these are supposed to be perfect squares, a squared and b squared. This is not a perfect square. If it was 4x squared, it would be, because it'd be 2x times 2x, but this is a 2x. So we got to remember that first rule, a lot of times that we use, greatest common factor. We can factor out a 2 first. Y minus 47. I'm going to leave a little space there because I know I'm going to add a number to it, like I did up here. Equals, and let's factor out a 2. I'll leave a little space there. So if I factor out a 2, now I have an x squared. That's great. I need this to be a perfect square, so I can make this a perfect square trinomial. So again, I take the middle coefficient, negative 10, and I divide that by 2. And that gives me negative 5. So already I know that this is going to be x negative 5 squared, because that's the number I get when I cut it in half. And then I'm going to square that to figure out what I'm adding. Negative 5 squared is plus 25. Let me ask you a question here, and this is a chance to participate in the chat. I have to make both sides equal, right? If I add 25 over here, what do I need to do over here? And yes, this is a trick question, so look very closely to see if you can figure out the answer, because this is a trick question. I'm telling you up front. Up here, I added 81 over here, so I had to add 81 over here, because if I didn't, that changes the equation. But I can always, if I do the same thing to both sides, I haven't changed anything. So I added 25 over here. What do I need to do on the left side? If you think you haven't figured it out, put in the chat. Bethany says, do you add 50? John says you already subtracted 47, so can you subtract 25 also? Okay, with a couple of different theories here. Because I'm going from this to this, and I want it to be the same equation. I don't want, because right now this is a totally different equation, because now this side no longer equals this side. These are still equal, because all I did is I moved the 47 to the other side. So they're still equal, but they're no longer equal. This is a different equation as it stands right now. And I'll tell you, Bethany's actually got it. Everything inside these parentheses is being multiplied by 2. So I did not add 25 to this side. I added 50. I added 50 to this side because everything inside the parentheses is being doubled. So if I add 50 to this side, now these are equal again. Up here, I didn't have to worry about that. I didn't have a coefficient out front. This was just adding 81. There wasn't anything multiple. It's not in parentheses. I don't have a number out front. It's just a 1, really, because I don't have a number out there. Just a 1. This one, there was a 2 out front, so I have to be very careful or I'm going to entirely change the equation. Add 50. So this does have a 2 out front, and this becomes y minus 47 plus 50, y plus 3. So let's move the 3 back over here. And the vertex form, x minus 5 squared minus 3. So the vertex, h is 5, k is negative 3. 5, negative 3 is the vertex. Tricky. I told you it was a trick question. I added 25, added 25. No. I added 25, which means I have to add 50 because that's going to be doubled. All right, let's graph this just to prove to ourselves that these are the same equations. That this is the standard form and this is the vertex form of the exact same equation. So here, I'll bring that down a little bit because we're going to look at it in a minute.
You're wondering, hey, did I do it? Let me know.
We're going to check it in a minute. So let me type this in first.
The only one I have to do is center.
2x squared minus 20x plus 47. Oh, I put s, x. There we go. And then the vertex form is y equals 2 times x minus 5 squared. I said minus 3. All right, let's go look and see if these are. Okay, there's the red one. There's the green one. They're the exact same graph. So they must be the exact same equation. Same thing. And where's the vertex? 5, negative 3. There you go. Just as we predicted, 5, negative 3 should be the vertex. All right. So there's a couple of examples of how we can take completing the square and take a standard quadratic equation and make it vertex form. But let's see, what else is that good for? We can actually use that to solve a quadratic equation. So let's draw another line. Let's say we have this quadratic equation, y equals x squared minus 18x minus 27. We said, okay, we want to solve this quadratic equation. Well, maybe we can just factor it, right? Because we can solve it by factoring. So we need something that equals negative 27 and adds up to negative 18. So let's take the factors of negative 27. That'd be, and the bigger one would have to be the negative one. So 1 and negative 27, 3 and negative 9. That's about it, isn't it? There's nothing else that multiplies together to be negative 27. Well, if we add these together, it's negative 26. If we add these together, it's negative 6. Well, none of those add to negative 18. Okay, we can't factor this. Well, that means it doesn't have nice integer solutions. Means it's going to have some kind of weird solution. So there's a way to check what kind of solution it has. If we take b squared minus 4ac, you're like, what do you mean b squared minus 4ac? I mean, when we go to the standard form, y equals ax squared plus bx plus c, right? That's the standard form. We can take the a, b, and c and put it into this. This is called the discriminant, and we'll see it again in just a few minutes. B squared minus 4ac, b, negative 18. Negative 18 squared minus 4 times a is 1, times c is negative 27. All right, let's pull up our calculator. We don't want to mess this up. There's a lot of big numbers here. All right, so if we're taking this, negative 18 squared. So let's do 18 negative, and then square that. That's 324. Minus 4 times 1 times negative 27. Well, we don't have to do the times 1, but 4 times negative 27 is negative 108. So 324 minus negative 108. So let's see, 324 minus 108 negative. So minus a negative 108 is 432. So the discriminant is 432. If we take the square root of that, it's not a nice number. The square root is 20.78 dot, dot, dot. It continues. So what that tells us is if this is not a perfect square, and 432 is not a perfect square because the square root is not an integer, that means that the answer to this is two irrational solutions.
Okay. So I'm going to leave this screen on, my screen, while you're working.
That's what it tells us. Two irrational solutions. What's irrational? Well, that means it's like 5/3 or the square root of 9 is in it. It's some, well, it's not 5/3 because that's actually a rational solution. Irrational solutions mean it has some number in there that's going to be a repeating decimal. Not going to be a nice x equals 3. It's going to be x equals 2 plus the square root of 7 or something weird like that. So that's why it's not going to factor. If this would have been like the square root of 49, then there are two rational solutions. Right? It means it might be an integer, it might be 1/2 or something. There'll be rational solutions. If this is a negative number, what if it was negative 432? That means two complex solutions. That means that would be two imaginary solutions. It means if we graphed it, we would never see it touch the x-axis. If this discriminant, if this, when we calculate that, if that ends up a negative number, because when we take the square root of it, it'd be an imaginary number. And if we do this and it equals 0, that means there's one solution. Just one solution. Which means it's the same solution twice, right? Because we know there's two solutions because it's x squared. All right, so what have we learned? We haven't made any progress yet in finding the solution. I'm just showing you that all the methods that we think about in factoring are not going to help us. We're not going to get the answer. Let's try completing the square to actually solve this, not to convert it, but to actually solve this. So to solve it, let's set it equal to 0, because that's how you solve the quadratic equation, right? We set it equal to 0, not equal to y, equal to 0. And we're going to try to solve this. Is this the one I want to solve? Yeah, that's the one I want to solve. All right. This is the same one we did up here. But this time we're actually trying to find the solutions. We know the vertex form. So we've graphed it, but what are the places where it crosses the x-axis? So let's move the 27 over here. Plus 27. So this is 27 equals x squared minus 18x. Now we've already done the work up here to know with 18x, we divide the negative 18 divided by 2, square it, and we add 81, which means we have to add 81 over here too. So now 108 equals x minus 9 squared. Like, ooh, okay. Now I'm not going to move it over there. I'm not looking for vertex form. I'm looking to solve this. I'm trying to solve for x. So right now the x is being squared. Everything in this parenthesis is being squared. So I got to take the square root. Square root of 108 equals x minus 9. Because these cancel out. The square root and squaring cancels out. So it just leaves the x minus 9. What is the square root of 108? Well, it's not a perfect square, because if we just take 108, clear it, 108 square root. See, it's not an integer. Can we simplify it? Well, yes, I believe we can, because 108 is the same as 36 times 3. Oh, I closed my calculator. I didn't shrink it down. Let me open that back up. 36 times 3 is 108. See that? That's it. 108 equals x minus 9. Well, the square root of 36 is plus or minus 6. square roots of 3. And this is x equals 9. I mean, x minus 9. So if we add 9 to both sides, x equals 9 plus or minus 6 square roots of 3. And that's the answer. 9 plus or minus 6 square roots of 3. That's the two x's. If you were graphing that, you're like, I don't even know what that number is. It's a number. Yeah, it's actually a number. Let's put it in our calculator and see what the two x's are. This is where it would cross the x-axis. So one of them is 9 plus 6 square roots of 3. And the other one is 9 minus 6 square roots of 3, because this is plus or minus. So both of those are the answer. So let's see if we graphed it. What is 9 plus 6 square roots of 3? All right, so clear. 9 plus 6 times the square root of 3 equals 19. So this would be at 19.39. .392. So a little bit over 19. That is one of the solutions. We would only do this when graphing. So we'll talk about that in just a second. Let's do 9 minus 6 times the square root of 3. And that's negative 1.392. All right, let's talk about this. The solutions. The solutions are this right here. If I say, what are the solutions to this equation? You're giving me those two numbers because those are exactly correct. These are rounded. These are not the solution. This we need, if we graph this equation, that's when we need to know that. Graphing. So if I ask for the solutions, you're giving me the solutions. If I ask you to graph it, that's when you need to know what the number is as a decimal. So let's look at this because we graphed this before. Let's see if that's the x-intercepts. That's the numbers that should be the x-intercepts. So let's get rid of this. Go back to this other equation that we just looked at. X squared minus 18x minus 27. Let's see. 19.392. 19.392, and the other one should be a negative 1.392. Look at that. That's exactly correct. Those are the solutions, because when we graph it, that's where it crosses the x-axis. That's where it crosses the x-axis. So that's when we use the decimal number, only to graph it. But the solutions is this exact number. This is exactly the right number. This is the rounded number we can use to graph it. All right, so that's completing the square. That's completing the square. You move anything over that's a constant to the other side. You take the coefficient, cut it in half, square it, and add that to both sides. And then it's just a matter of simplifying. All right, because this simplifies to x minus 9 squared. Move that back over, and you can get the vertex form. Or if you're setting it equal to 0, same problem. We're just solving it now. Instead of moving the 108 over, we take the square root of both sides, and that helps us solve it. All right. That was 3.05. So when you go to Buzz, if you look at lesson 3.05, this is what it's talking about. This is what it's doing. And there are extra examples in that. You can go to 3.05, look at the examples, and work some of them. If you don't practice this, it's going to look like you're studying Greek when you look at the test. You're like, how in the world do you do that? Well, practice it. If you practice it, it gets easy. Now let's look at 3.06. And let's talk about solving quadratic equations. All right, that's not totally new to us. Let's look at like something pretty simple. X squared equals 9. X squared equals 9. And we want to solve. That's a quadratic equation. Right? If we move this to the other side, then you got x squared minus 9 equals 0. That might look a little bit more like a quadratic equation like you think of. Oh, yeah, x squared. There's just no x term. And if I say, what's the solutions for that? Well, there's a couple of ways you could do that. If we went back to this and we said x squared equals 9, and I want to know the solutions, I just need to find out what x is. So the square root of x squared is just x, and the square root of 9 is plus 3 and minus 3. So there's the answers. Right? Oh, you're right. That's the answers. That's easy. I could also get it from here because we've learned that this is a square, this is a square, and this is the difference. So this is the difference of squares. So we know that using our little factoring cheat, it's x plus 3, x minus 3 equals 0. So if x equals 3, x plus 3 equals 0. X equals negative 3 is one of our answers. And if x minus 3 equals 0, add 3 to both sides, and x equals 3. There's our two answers, which is exactly the same two answers we got up here. Negative 3 and 3. So we can do some simple ones like that. All right. Difference of squares, or just taking the square root and solving it that way. What else could we do? Let's see. How about if we have an equation that looks like this? X squared minus 4x. Let's say x squared. Let's say x squared equals. X squared equals negative 4x. Do it that way. All right. We know it's got two solutions because it's a quadratic equation. It's an x squared. How would you tackle that? What's your thoughts? I'll give you a chance to put that in the chat. How would you do that? There's more than one way to do it. I'll tell you that. So what you're thinking may be correct. Generally, to solve a quadratic equation, you move everything to one side. Let's do this. X squared plus. So it'd be x squared plus 4x equals 0. You can do that. Does that make it easier to solve? So from here, we could do x squared plus 4x equals 0 and complete the square. So 4 divided by 2 is 2, and then we square that. So we add 4 to both sides. So we've got x squared plus 4x plus 4 equals 4. We know this is x plus 2 squared equals 4. So we can take the square root of both sides to solve it. So we got x plus 2 equals plus or minus 2.
I feel you. I feel your pain. I wish.
And then subtract 2 from both sides. So we got two different solutions. We got x plus 2 equals 2, and we got x plus 2 equals negative 2. We need to separate that because this is plus or minus 2. So let's break those up. Two different solutions. So if we subtract 2 here, x equals 0. We subtract 2 here, x equals negative 4. There's our two solutions. Completing the square. We can also factor. Factor out an x. See, both terms have an x, greatest common factor. So that means x equals 0 is one of our solutions, and x plus 4 equals 0 is the other one. Subtract 4, x equals negative 4. Either way, got the same two answers. X equals 0, x equals -4. So you have to realize, get that pencil sharpener, we're using it a lot today, that there's more than one way to solve quadratic equation. We did that one by factoring out the greatest common factor. Set it equal to 0. Set it equal to 0 first, actually. Factor out greatest common factor and find a solution. This one we did completing the square again. Either way, we've got the same answer. Let's try this one. 2x squared plus 10x equals 48. And you're like, oh, well, how about that completing the square thing? Again, you can do it a lot of different ways, but here's the key. Some ways are harder than others, depending on the equation. On this, factoring was real easy, and completing the square wasn't bad. Let's see, completing the square here. This is not a perfect square, so we need to factor a 2 out. So this becomes x squared plus 5x. So now we've got that perfect square equals 48. Then we take the 5 and we divide it by 2. Uh-oh. Well, that's 5 halves. Or 2.5, but we're going to deal with fractions here. So then we'd square that, and that's 25 fourths.
It's not that, Anthony. Open it up.
Now we had 25 fourths to both sides. Oh, that's actually wrong. This would be because we got a 2 out here, so we got to add 50 fourths over here. We got to double it. And now we look at this and go, okay, Mr. Brock, I do not like that. I do not like that at all.
We talked about this last week, Anthony. I know because you told Ken that.
Okay, so now Sean's saying, well, why don't we just make it standard form? Yeah, because this completing the square looks like that's going to suck, right? Yeah, let's do that instead, Sean. I like that. Let's subtract 48 from both sides. So instead, that would give us 2x squared plus 10x minus 48 equals 0. Okay, so now we got a totally different type of thing. Maybe we can just use factoring because completing the square gets ugly. Yeah, we could do it that way, but that gets ugly. So this, we should probably go ahead and factor out the 2. So we got x squared plus 5x minus 24 equals 0. Now let's see if we can, find factors of negative 24 that would add up to be positive 5. So the bigger number would be a positive. So 24 is negative 1 and 24. That'd be negative 24. Negative 2 and a positive 12. Negative 3 and a positive 8. Negative 4 and a positive 6. Let's see if we add these. That's 23. 10. Oh, that's 5. That's what we want. So we can do 2x minus 3 and x plus 8.
You've been sitting on that same question for about 5 minutes.
Since negative 3 plus 8 is 5, and negative 3 times 8 is negative 24. That works. So then the solutions are, let's see, we got to take each factor. 2 equals 0. No, that one gets thrown out because 2 does not equal 0. X minus 3 equals 0. So add 3. X equals 3. There's one of our solutions. Or x plus 8 equals 0. Subtract 8. X equals negative 8. So in this case, factoring was a lot easier than completing the square because that got ugly right away. Well, let's try another one and see which method's going to work better now. How about x squared minus 4x equals 9? Well, let's try Sean's factoring method first. Let's just set this equal to 0. So we'll subtract 9. So this is x squared minus 4x minus 9 equals 0. So we need the factors of negative 9. And the larger one has to be a negative now. So negative 9 is only, see, 1 and negative 9, and then 3 and negative 3, and that's it. Nothing else multiplies b negative 9. So we add these together, that's negative 8. Add these together. Well, that doesn't work on this one. This one doesn't factor because nothing equals negative 4. So that's out. No factoring. We could, as an option on that last one, if you like the factoring by grouping, because some of you guys have trouble for getting this step to this step. So let me look. Since we found that this works, okay, I'm gonna interrupt that step right there. Here, let me do this. So I'm gonna stop that step right there. We could go from this then to 2 times x squared minus 3x plus 8x minus 24, because I want to show you this. So some people like to do it this way. See, in this case, I just took the 5x and I made it a negative 3 plus 8. That's the same thing. That's 5, right? Because negative 3x plus 8x equals 5x. So that equals each other. So instead of that 5x, I said I'm going to use a negative 3 and a plus 8. So then I can factor like this. Grouping, I can factor an x out, and that leaves x minus 3. And here I can factor an 8 out, and that leaves x minus 3. So then in this term, x minus 3 can be factored out. There's still a 2 out front. And that leaves x plus 8, because x minus 3 is factored out of there too. Which notice ends up right back at the same place. So if you need to group them first to get back to this same point, or if you can just go straight in the 2 factors. But let's not forget, factoring by grouping is another way. Factoring or factoring by grouping. Either way, it'll get you to the same place, and then you still end up with these 2 answers. But this wouldn't factor by grouping either, because it didn't factor. There's no factors. So that leaves us down to really 2 good choices. Completing the square, or the one we haven't discussed, the quadratic formula. Yeah, I didn't write that very good. I'm not writing good today. Quadratic formula. So, is this always the options? Well, if you complete the square, that's only going to work when this is a square. If this was a 3x squared, we might not want to try that because we have to factor out a 3. We get back to a fraction. So sometimes this would be easy. But sometimes you're going to end up dealing with fractions, and you may not want to do that. Quadratic formula always works. And I'm gonna put that in red. The quadratic formula will work with every quadratic equation, regardless. Always, always. Even when it has like an imaginary solution, the quadratic formula will find it. You can find it with completing the square, but sometimes you're going to be dealing with some pretty nasty fractions, and you may get lost. Let's write down what the quadratic formula is. It is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And you're like, okay, I see a lot of alphabet in there. I don't see where you're putting numbers in there. And this is when you have standard form of a x squared plus b x plus c. That's where your a, b, and c come from. Your a, b, and c come from right there. And you substitute them in right up there. So for this, we do have an a, b, and c, and we'll do it like this. A equals, what's the coefficient of x squared? Because that's what the a is. Well, in our case, it's 1. What's the coefficient of the x? That's b. Our b is -4. All right, what's the coefficient, or what's the constant? The constant's -9. So our c is -9. So let's take this and plug this into the quadratic formula, because it always works and will always give us the answer. So x equals -b. Well, b is a -4. So it's -4. Plus or minus, because that gives us two solutions. The square root of b squared. Well, again, b was -4. Okay. Minus 4 times a. Oh, 4 times a. So 1 times c times -9. And all of that is over 2 times the a, which is 1. All right, so there it is, color coded. All the B's are blue, all the red is A, and C is green. So now let's simplify. X equals, what's -4? Well, that's a +4. Plus or minus the square root of, all right, 16 minus 4 times 1 times -9. So -4 is 16.
Anthony.
Minus, what's -4 times 1? That's -4.
Thank you, sir.
Oh, wait, we're doing subtracting. So let's do 4 times 1. Subtracting, 4 times 1 is 4. 4 times 9 is -36. So this becomes -36. All over 2. Okay, so continuing to simplify. X equals 4 plus or minus the square root of 16 minus a -36. That means plus 36. 16 plus 36 is 52. Divided by 2. Oh, can we simplify that any? Well, that is the same thing as 4 over 2 plus or minus the square root of 52 over 2. So that would simplify to just 2 plus or minus the square root of 52 over 2. Now the question is, can we simplify the square root of 52? I mean, this is the answer, but it's not totally simplified because 52 is 4 times 13. Four times 13 is 52. So that means we can rewrite the square root of 52 is the same thing as the square root of 4 times the square root of 13. Okay, which is also square root of 4 times 13. You could put them underneath it, but we're separating them because what's the square root of 4? That's 2. 2 square roots of 13. So the answer here then becomes 2 plus or minus 2 square roots of 13 divided by 2. Well, 2 divided by 2 cancels each other out. So our final answer, 2 plus or minus the square root of 13. That's why it didn't factor, because it had some kind of weird, irrational solution. 2 plus or minus square root of 13. Quadratic formula always works. Always, always, always. I have a 2.5-minute video I will post for you to watch that might be entertaining to you, but it talks about the quadratic formula. 2 plus or minus the square root of 13. Always works. Let's see. Let's do one more of these before we look at the last lesson. How we're doing on time? We've been here an hour. Okay. 3x squared equals negative 11x minus 6. So let's move everything to this side. Let's make it 3x squared. We're going to add 11x to both sides. That would add 11x on this side. We're going to add 6 to both sides. So that side becomes 0. So 3x squared plus 11x plus 6. So again, we can see, does this factor? So we'd have to take 3 times 6, factors of 18. Everything's positive. So what are the factors of 18? And do any of them add up to 11? 1 times 18, 2 times 9. Oh, 2 times 9 is 18. So we can do this as factor by grouping. 3x squared. We'll make this 2x plus 9x plus 6. See, we just took 11 and broke it, because this is the same thing, right? 11 and then 2 plus 9. So I just rewrote it. So now I can group it. So what's in common here? They both have an x. So what's left? 3x plus 2. 9x plus 6. Well, we can factor a 3 out of there, and 3 out of that is 3x, and 3 out of that is 2. So now this term and this term both have a 3x plus 2. So let's factor out that 3x plus 2. What's that leave? It leaves x here and plus 3 there. So our two solutions are 3x plus 2 equals 0. So subtract 2. 3x equals negative 2. Divide by 3. X equals negative 2/3. Or x plus 3 equals 0. X equals negative 3. Negative 2/3 and negative 3. If I want to check that, I can type that into Desmos. I always like double checking my work. And I can type it exactly like it started. I don't have to go down to this one. I can say 3x squared equals negative 11x minus 6, and it'll graph it for me. Ooh, look at that. It's a really very, very, very skinny. Very skinny. I'd have to do complete the square to see where the vertex is, because it's not anywhere close to the axis here. But I was looking for the two solutions. No, that's negative 2/3. That was one of our solutions, right? Negative 2/3. That'd be 0.66666 repeating, negative. And the other solution we said was negative 3. Negative 3. Negative 2/3, negative 3. So we got the solutions right. We graphed it to double check ourselves. There's my work, and I double checked it. I could also double check it by substituting negative 3 in here for x and seeing if those do equal each other, and substituting negative 2/3 in there and see if they do equal each other. Now, multiplying negative 11 times negative 2/3 is going to give you some fractions, which won't be fun. And taking negative 2/3 and squaring it and then multiply by 3 won't be fun, but they should equal each other. That's another way to double check that. All right, so that is lesson 3.06, ways to solve quadratic equations. Remembering that this always works. You can always use the quadratic formula. So you should have that in your notes for sure. Always works, quadratic formula. So let's look at our last lesson, 3.07. This won't take long because it's nothing new really from 3.06, because it's also solving quadratic formulas. X squared minus 6x plus 12 equals 0. Like, okay, you're like, great. So plus 12 negative 6. So that would be either negative 1 times negative 12, negative 2 times negative 6, or negative 3 times negative 4. That's the only choices. Oh, focus. All right, that's the only choices. Equal positive 12 and have a negative. So this would be negative 13. This is negative 8. This is negative 7. None of them add up to negative 6. So no factoring. No grouping, which is another form of factoring. Those are both thrown out because it doesn't factor. So no factoring by grouping. We could complete the square, or we can use the quadratic formula. Let's try completing the square first. Since this one looks like a nice one, it's just an x squared. It's not a 3x squared or a 5x squared. It's just x squared. So let's subtract 12 from both sides. We'll leave some space. So negative 6 divided by 2 is negative 3. And then we square it. So we're adding 9 to both sides. So this becomes x minus 3 squared. And this becomes negative 3. Uh-oh. I'm solving for x. I'm not trying to write it in vertex form. I'm solving for x, which means I have to take the square root. The square root of x minus 3 squared is just x minus 3, because remember, they cancel each other out, squaring and square rooting, equals the square root of negative 3. Square root of negative 3, that's imaginary. Yeah, so x minus 3 equals I square roots of 3. But I forgot this. If I took the square root, it's plus or minus. It could be plus the square root of negative 3 or minus the square root of negative 3. All right, so add 3 to both sides. And the answer is x equals 3 plus I square roots of 3 and 3 minus I square roots of 3. I could have just said plus or minus right here. Same thing. But I just wrote them separately to show there is 2 separate solutions. But when you graph it, this won't help you because these are imaginary. If you graph it, in fact, let's do that. X squared minus 6x, x squared minus 6x plus 12. Look, it doesn't touch the x-axis. It doesn't go down below 3, 3. It won't tell you the solutions because the solutions are not real solutions. They have to be real solutions to show up on a graph. These are imaginary solutions. We could also have used the quadratic formula because it always works. Let's do one more, and then I'll let you guys go tackle the day here. X squared plus 3x equals negative 6. All right, if we're going to solve it, we need to set it equal to 0. So add 6. X squared plus 3x plus 6 equals 0. Already looking at it, I don't want to complete the square with this one. Because if I cut this in half, it's a fraction. Right? Because that's what I would do it, complete the square. We take that middle number and we divide it by 2. Well, 3 divided by 2 is a fraction. So I do not want to complete the square. So that puts me back to the quadratic formula. Negative b plus or minus the square root b squared minus 4ac over 2a. Right back here. A equals 1. B equals 3. C equals 6. Yeah, I have that in standard form. Don't do that up here. You'll get your C wrong because it's not negative 6. Move it over and set it equals 0 before you determine what each one is. So x equals negative b, negative 3, plus or minus the square root of b squared, 3 squared. We'll go ahead and just make that a 9, minus 4 times a, that's just 1. I'm not going to write that then, times c, over 2 times 1. So x equals negative 3 plus or minus 9 minus 4 times 6. 9 minus 4 times 6. The square root of negative 15. 9 minus 24, negative 15, over 2. So our final solutions, negative 3 plus or minus I, we need to pull that I out, because that's square root of negative 1 times the square root of 15, and negative 1, square root of negative 1 is I. 15 over 2. Yeah, that's our answer. If you wanted to break that up, this is the exact same number. We would generally leave it like that because that's clean and neat. See, because we breaking it apart, we still can't simplify it. We still can't simplify it because 3 divided by 2 is still a fraction. I divided by 2. See, so we just leave it like that. We only break it apart. If this is like a negative 4, then we could simplify this just to negative 2. Right? But since this is still a fraction, this is totally acceptable. This is always acceptable, just to leave it combined. But again, quadratic formula. Not difficult. Just plug in A, B, and C, and then just simplify. There's where we plugged it in. Simplify it to that. Simplify it there by just pulling the I out. Because that's all it can simplify. Square root of 15, there's nothing to simplify. So that is 3.07. The only difference between 3.06 and 3.07 is 3.07. 3.06 is solving quadratic equations. 3.07 is solving quadratic equations with complex solutions. What's a complex solution? Imaginary solution. So it's the same thing. Solving quadratics or solving quadratics with imaginary solutions. It's still just solving quadratics. So our 3 lessons all have 5 multiple choice questions. So make sure you can do that. Basically, all today was a lot of just repetition, because the first lesson was just showing us how to solve quadratic equations by completing the square. But remember, we also used it to convert from standard to vertex. So completing the square does have a purpose other than just solving quadratic equations. We can also complete it to make that perfect square trinomial. So I'll get this video edited. I'll get it in Google Classroom hopefully this afternoon. And I'll also have another 2.5-minute video you got to watch about the quadratic formula. Just something fun that I recorded out in the middle of the park. Just having fun. All right, if you got any questions, hang around. Otherwise, go do your grade checks. It's Tuesday, right? Oh, yeah. You might as well get started on that before advisory. Have a great day, guys. Bye.